So it's 3 p.m. so we should get started. Let's switch to the main camera. And hello everyone, and welcome to a new episode of the Untitled WebDev stream. My name is Lucas, and in today's episode we will be talking about functional programming. So in all the previous episodes, I basically just teased this topic, basically because I have a big tendency to try to develop in a functional programming way. But today's idea is to just focus on that programming paradigm and talk a little bit about how you can code in that style using web development using JavaScript or TypeScript. But yeah, I already gave a talk about this in Spanish a few months back in some kind of conference that we have in our hometown, in my hometown called Barcamp. So I already talked about this in Spanish, but I wanted to share that same knowledge in English as well, and add it to the topics that I shown in the Untitled WebDev stream, mainly because every time I show a piece of code is basically based in this same paradigm, so I want to make the paradigm clear for everyone before continuing with other topics, okay? So the idea will be to show you a small presentation similar to the one I show you with progressive web apps, but this time focus on functional programming. The main difference with this one is that I will be switching between code and the presentation back and forth. So yeah, if you have any questions, as usual, just interrupt me at any point in the chat and just write the questions you have, and we can just go ahead and solve them if I have the knowledge to solve them. And if you are seeing this video later on YouTube, as usual, you can just add a comment down below, and I will try to answer it in the comment section itself, or if it's worth the time and the explanation, I could take some time in the next stream and just focus on that on those questions, okay? So let's switch to desktop. The topic of today's stream is functional programming then. So let's try to see if this works. Yeah. So before I carry on, this programming paradigm or this programming this programming style is not a new thing, right? So this has been here since the 80s. So pretty much it was born together with languages like C++ or C# and stuff like that. So it's it's a predecessor of those. So it's not that it's some kind of we went through object-oriented programming and then we reach functional programming or something like that. It's not the next step. Both object-oriented programming and functional programming can go hand by hand. So it's another paradigm, but they can work together basically. Okay, so. I had a joke in here yeah, it's in here since the 80s, so it could be approved by ELF even, so it's as old as ELF. So yeah, the thing is, when I was curious about this, and maybe you as well while watching this video were curious about this topic, I started looking at the definition of this in Wikipedia, what is functional programming. And the definition I found is it's a programming paradigm where programs are constructed by applying a composition. It's kind of what, right? So it's super confusing, and it didn't give me any kind of tips or where should I get started or how can I do functional programming myself or something like that. So instead of looking at the definition, I thought maybe I can go ahead and ask some functional programming folks, so people that are already working for functional programming. So I started looking at functional programming Slack channels and different topics on Reddit and stuff like that in order to try to figure out what functional programming was. And the thing is when I asked them, they basically say yeah, before starting with functional programming, you need to learn about category theory, math, and then about concepts like functors, monads, setoids, or semigrupos, what? It's I wanted to get my hands dirty with functional programming, but this was kind of like tedious and hard and like super heavy, so I wasn't happy at all with this. So basically my reaction was like, bro, I'm a web developer. It's like I just do like JavaScript, TypeScript, HTML, CSS. So I don't want to learn about like math and monads and stuff like that. A general misconception, if you are programming yourself, you know this. It's like a general misconception of like the general public or whatever is that in order to be a programmer, you need to be good at math, and that's actually not true. It's that, yeah, you need to understand like basic concepts like, I don't know, like addition and subtraction and stuff like that, or maybe like do a basic equation. But like the general programming knowledge comes with like actual logic, not like mathematical logic, like general logic, and it's expressed through words, not through like variables and like just numbers, right? So yeah, my reaction was this one. But then after like talking with functional programming folks and like looking like for the definition or whatever, I thought maybe looking for a functional programming language will be like the correct approach, because I could learn that language and then learn the paradigm together with that language, okay? So I started looking for functional programming languages, and I found Haskell and Erlang were the two more like the most mentioned ones about functional programming. Haskell is the most popular one, and it's already like super old, but fortunately for me, as a web developer, JavaScript and /TypeScript is a functional programming language as well. So you can do functional programming with JavaScript or TypeScript, right? So like switching back and forth between the language that I already knew, JavaScript, and functional programming, I came up with this kind of like definition of what functional programming is. So functional programming, like for humans basically, is a way of coding stuff that makes our code easier to understand. So the general like output of our code, like not the output but the actual code, is easier to understand, is easier to maintain. So if you have any kind of issues or you want to patch a bug or something like that, it's far easier with functional programming. It's easier to extend and reuse. So basically, if you want to code some kind of like useful thing for you, you can reuse that in other projects. So for example, you could have like your own library of utils that for your like your products, and use that same library over and over again, so you have like a lot of reuse. And it's also super easy to extend, so you can like have some basic behaviors that you put together in order to produce something new, okay? So to achieve this, we need to follow a certain line of conventions. Basically, I say conventions and not rules, because they are not set on stone. It's not like as soon as you follow these rules, you can go back. I mean, we are still working with JavaScript. It's still like a language that supports stuff that is not functional. But the idea is to try to follow these conventions in order to achieve all this easy to understand, easy to maintain, extend, and reuse, right? So the conventions could be interpreted as just a simplification, a general simplification of how to code, right? So all the rules we have in order to achieve functional programming in JavaScript are basically to just forget about some stuff that makes the JavaScript development harder, okay? So basically, how we make JavaScript a functional programming, so we make JavaScript an easier programming language by just removing the hard stuff, okay? So in order to achieve this simplification, we can just forget about stuff like classes, control structures, or variables. So basically, we don't use the class, extends, and stuff like that, or all those words. We don't use that. We don't use control structures, and what I mean by this is stuff like if, for, while, all that stuff that we learn on like normal programming when you go to like the university or your like IT school or whatever. When you are learning programming, you learn stuff like if, for, while, all those control structures. So the idea will be to forget about those, don't think about those, and don't use those, okay? And also forget about variables. That doesn't mean that we can't save data. We will talk about that in like a second. But we don't use variables, so stuff that can change over time, okay? Not only we forget about this, but we also forget about all the complexities that these things introduce. So if we forget about classes, we can forget about like inheritance and like all the extends stuff and calling super and all that complexity. We forget about that and we can focus on only the simple stuff, okay? So instead of using these things, we basically use what are called pure functions. We will see what are those in like a second, but like you can see like in there, I can point from here, like in there, let's use the cursor. Pure in here, I'm like highlighting the pure word because that's the important thing. It's just a function that follows a certain like some rules or conventions as well, okay? Then we use the primitive types. That means like we use numbers, strings, booleans, the stuff that I show you in previous streams, basically. Then we use arrays or plain objects. So arrays, as I show you, is just a list of things, and a plain object is just also some kind of like a list, but we have a name associated with every value, okay? We use constants instead of variables, so that means that we save data, but we never change it. And you might think like, but data change over time. Yeah, but we have ways of solving that, just wait a minute. And then we use operators like the plus sign, the minus sign, the ternary operator, nullish coalescence, and stuff like that. So we will see that in like a second. With all these 5 things in here on the right side, we can achieve everything that we can achieve with the things on the left, but without using that. So basically we are simplifying the language by just using like a subset of the stuff that the language offers. Instead of using everything it has, we only use a part of that. An analogy for this could be like, for example, think about like a car. If you are like, you could know about like how the engine works and how that how it transforms like the gas into like movement and stuff like that, but you actually don't think about that. You just use like the wheel and like the pedals and stuff like that. And I'm using like an analogy with cars when I don't have one, but yeah, whatever. So basically you just think about a subset of the car. You don't think about the entire car and how it works in order to make it work, right? So yeah, I mentioned in the previous slide a thing called pure functions. So functions that are pure. But it's not like a new syntax or that you need to write stuff super differently or something like that. It's just functions, like regular functions, like the ones that you use constantly if you are working with JavaScript. But basically you follow yet another set of conventions in order to make them pure, okay? So these conventions are, first, that given the same input, we provide the same output. So let's say that we have a function that takes a number and we return that same number plus 1. Okay, so for example, if we provide a 2, that function returns a 3. Okay, this rule that says same input, same output basically means that every time we receive a 2, we should be returning a 3, never a 4 or a 5 or a 6 or anything like that. Every time we receive a 2, we have a 3. So every time we have the same input, we have the same output. That never changes, okay? So that's one of the rules of a pure function. The other one is no side effects. This is similar, like, I'm not talking about like as soon as you write a line of code, suddenly you have like a tentacle coming out from your neck or something like that. I'm talking about like, your function doesn't change anything of the outside world. Meaning that, for example, you have a function that receives a variable with a number. We don't change that value. We just take that value and do something with it, but we never change the actual value that we received, okay? So that's the meaning of no side effects. We don't affect something that is on the sides, basically, okay? So we just work with some values, but we don't change anything from the outside world. We also don't rely on external state. So this means that basically we not only not change something from the outside world, but we don't receive stuff from the outside world. We don't rely on stuff of the outside world. Meaning that in order to make our function pure, first it takes something and returns always the same thing, but it doesn't change anything that it receives, and it doesn't rely on stuff that is on the outside world. In order to make this a little bit more clear, let's switch to the code and actually see that working. So I have in here, let's make it bigger. I have in here an example for pure functions, okay? So in here I have like, let's say like the bad example, bad stuff that can happen, okay? So in here we have this let step first. So we have some kind of like variable. I think I can make it even bigger. Yeah. So we have this let step, right? So we have a variable called step, and the value for that is 1. That's because I want to, every time I call this add function, I want to add 1 to whatever value I receive, okay? So I put the step in here because it's, I don't know, easier or faster or whatever. So I have this let in here, okay? So I expect this function to, every time I call add, to add 1, okay? So I'm doing like a step plus the value, so I'm returning that. So basically I'm expecting to be, if I have a 1 in here and a 1 in here, I have a 2. So yeah, I have the output that I wanted. But if I call the function again exactly with the same value, so I call again add with 1, I receive a 3 in here. Why is that, right? That's because every time I call this function, I'm changing the step value, okay? So I have side effects, basically. This add is changing something that is outside of the function, is changing this step. Not only is changing it, but it's also relying on it. So if I change the value in here to 5 or whatever, the value in here will change as well. So the first output will be something like 6 in here. And I don't want that. So I'm already violating 2 rules of functional programming. And not only that, we can see that we also violate the third one, that like the first one that I mentioned, but the third one of the 3. So I have this, every time I call add, I have a different value. And I just said that in functional programming, a function must always return the same value given the same input. So if I call add twice with 1, I should always get 2, not 3, okay? So for example, in here, I'm using exactly the same step because I want to subtract with the same amount, so 1. But when I subtract the 15, I get minus 12, and that's why, because I was in a 3 in here, so it's constantly changing, right? And if I call add again in here, I get like a minus 1, so what? It's like super unexpected, right? And this is like a super common issue with like projects in general. If you go to like any kind of like big project, they have these issues lying around all over the place, and that's because it's super usual to like just have some stuff lying around and use that. But if you try to follow the rules and make these functions pure, then these issues will never happen, basically, because pure functions are like predictable, they are easier to maintain. So let's turn this into an actual pure function, right? Pure function examples, because these two are not pure at all. So first, we want to get rid of this step in here because like I'm using the one outside. So for now, let's just remove it. We don't need that, okay? So now step is kind of missing. I think if I enable TS check in here, I will get, yeah, you can see like if I enable this, this is a trick for VS Code that basically gives me like type check inside of a JavaScript file, okay? But basically in here is like, hey, you are trying to add to some step value, but I don't know what the step value is, okay? So in order to fix this, we can just change this add function to have step here. Let's copy this, step, and this. And instead of assigning the add of step plus value, let's just return step plus value. right? Because why will ever want, we don't want to change the value of step, we just want to add step plus value, okay? So this basically changed the way add works, okay? So now add first takes the value of the step. So for example, we can just add in here a constant called add1, for example, okay? And that assign add, not as add, 1. And in here, instead of calling add every time, we just reuse this add1. So add1, add1, and add1, okay? So this effectively will be returning 2 every time we call it, because add1 is adding 1 to everything that it receives. If I hover over here, we could see that we are expecting a number and we return a number. So we are basically returning this part as add1, and step has the value that we submitted in here. So now every time we call add1 and a value, we add 1 to that. For example, we could have in here something like const add 10, for example, right? And have like add 10, and then we use this all over the place, like for example in here, let's say 10, and then this will be like 11, actually, because we are adding 10 to whatever we receive, okay? So as you can see, we already have some kind of reuse in here. This example is super minimal, right? It's just like adding 2 numbers, but the thing is, like, we already have some reuse because we are reusing this add function in here and in here. But with different uses, we have, for example, add1 or add 10, and it still works, okay? Not only that, but we are not relying anymore in an external step. We are just setting it in here. So, for example, in here we are setting the step to be 1, but we are not changing the value of step or relying in any external state. We are just using the step that we submitted in here, okay? The same applies for subtract, so we can just like copy this and paste it in here and just change it to subtract, subtract. Oh, without the S, right? Subtract, yeah. So subtract, and instead of plus, we have a minus in here. So with this, we have pretty much the same usage for add and subtract. So in here, we can say like const subtract 1, for example, and we call the function subtract with 1. So now every time we call subtract 1, we will be decrementing 1 to any value that we send. So for example, in here, if we did subtract 1, 15, this will be returning 14 because we are subtracting 1 to any value that we receive, okay? So let's switch back for a second. This pure functions has some pros and some cons, okay? So some things that are good and some things that are not that good, okay? So the pros, as you can see, is that they are reliable and easy to test. This means that if we want to test this, it's super easy because we are not relying on we don't need to define like an external state or anything like that. Every time we receive the same value, we have the same output. So it's super easy to test. If we want to test if this add 1 is working, we just do like add 1 and add another 1, and that should be a 2 always. So we don't need to like test in a scenario where the step has been set to 12 or anything like that. It's like it will always be like a predictable output. So it's super easy to actually test this, okay? It's also easier to read and reason about because we don't need to think like, hey, so I call add 1 in here, so if I call it again, maybe the value is 3. No, it will always be 2. So it's easier to actually like think about it because again, it's super predictable. The output will always be the same. So if I call this function like 1 time, 2 times, or like, I know, like 1,000 times, I will always get 2 if I put a 1 in here. So it's predictable, okay? And as you can see also, it's composable and reusable. So I created an add and a subtract that from those I can create other functions like add 1, add 10, add 1,000. and they will also be predictable, easy to use, and reusable. Okay, so we have all these benefits all the way around. The cons that we have is that if you think about that, user input is actually impure because we can't predict what the user will input. See, for example, if we have a function that takes a name, I will put in there like look, and you might put another value in there. Okay, so the user input is actually impure. It's not something that you can predict. Okay, and also the output itself is impure. Showing the values to the user is actually impure because if you think about that, it's an actual side effect. You are saying like, hey, for example, console log means like show something in the screen, right? But you don't know anything about how is that being shown. You just like saying, hey, screen, show that, but you don't have a way to actually predict that. Sorry, let's ban this spammer for a second. How I do this? Hit there. Report. It's a spam. Next. It's a bot. Next. Bot on stream. Yay! Submit report. And let's block it. There we go. Is it blocked? There you go. Sorry about that, a spammer in the chat. So, what's up? I was telling that basically user input is impure, so and user output is actually impure as well, because if we show something on the screen, or we, like, for example, we print something in the printer or something like that, if you even print, that's actually unpredictable. You don't know if that actually went through or if it's actually showing, so you can't test for that. For example, if I show something in the screen, I can test if the screen is actually showing that, because I don't know, it's like you need to put a camera and actually check if the value is showing, so that doesn't make any sense. So like we will have this question like lying around, like how can we communicate with the outside world, right? Because we can't receive any input because that's impure, and we can't send any output because that's also impure, right? So we can't. We will solve that in a second. Let's go to another factor of this, okay? So, immutability. Immutability was another of the steps that I mentioned to achieve functional programming, right? So this convention basically states that once you assign a value to a constant, so for example, let's say constant name equals look, okay? You never change that value. That value will stay the same, like, for it ad eternum, for eternity, okay? So if you need a new value, you just create a new constant for it, okay? And if you like know anything about like programming in general, like I know C++ or Java or anything like that, you might think like, but isn't this like super bad for like memory or processor or whatever? Like you are basically storing stuff constantly and never changing it, so you will end up like filling memory with stuff that you are not using. But the thing is like JavaScript is optimized for this, so it has like a really good what is called garbage collector, so it basically collects the garbage but from memory. So for example, let's say I have a constant that has the value name on it with my name on it, like look, like I just said, and then I want to have yet another one that is called full name that has like look Shiru, for example, right? So what happens with the previous one? It gets basically removed from memory if we don't use it anymore. So this doesn't even have like a problem with performance. It's just like a problem of the way we need to think about it. So again, let's see a little bit more of code. So we saw this pure functions example. Let's go to immutability, okay? So in this example, we have something similar to what I was mentioning, right? So I have this object in here called user. Let's say that we bring, we took that from like an API or from local storage or whatever, but we have this object, okay, that has a name, Luke, in here, and an age 30, okay? It should be like 31, actually, no, 30, there. So, yeah, I'm old. So, we have this user next year function, okay? The idea with this function is that it takes a user, okay, and we return the same user but with the age that the user will have next year. So we just need to add 1 to the age, basically, okay? So what we do in here is basically we take this user object and we do what is called a mutation in here. So we are going against immutability because we are actually mutating, changing the value of, okay? So we are changing value of the age and adding 1 to that. And then we return the user. So if we do user next year user in here, we saw already that it has the value of 31. So if we check the user next year age, the value is 32, so that's correct. But the thing is, like, after I run this function, in the next step in here, we have a problem because when we ask again, okay, so that's the, like, this is the age next year, but what's the age right now? We will get 32 again. And that's because this user next year function did something impure actually, but it did a mutation. So basically it changed the value of the original age to be 32. And we don't want that. We don't want to, every time we ask somebody how much, like, what will be your age next year, to make them older, right? Because if I call this function to know what the user age will be next year, like, I don't know, 3 times in a row, the problem with this is that we will get 33, 34, and the end in here we will get 32. So basically this function, every time I ask myself what my age will be next year, it makes me older. So that is not what we want, right? So we are actually making a mutation in here, and this is super unpredictable, and it happens like a lot also in like projects. If you work in any kind of like big project, you will see this lying around all over the place. But basically we are changing something that we shouldn't be changing. So for example, if in here is easy to spot because we have it like just next to each other. So like if we have like user next year and user age in here, we will see the 32 right away. But the problem with big projects is that maybe this function over here, this line 13, is run in, I don't know, in one like util function, or is run inside like a component or something like that. And this is in an entire different place. So when we compare the two values, it's like, why the user age is 32 if it's not being changed in here? So it's like the experience basically is like being like this. It's like we see this and we see this, right? So we are expecting the user to be 31, but for some reason we have 32. Why is that? Because this is being run in some place and it's mutating the original value, and it shouldn't, okay? So basically, to fix this, we need to make this function pure and at the same time make it avoid mutations, right? So return a new user with the value change. So how can we achieve that? Basically, we can just get rid of this for now, and we will be returning an object directly without having that assignment, okay? So first, I mentioned this a little bit a few minutes ago, we will be using operators a lot, right? So we will use this spread operator. This is a ... operator, okay? So we do that and we do user. This basically means I want to make a copy of everything inside the user object. So basically this line over here is the same as doing this. Name, user.name, and age, user.age. This is quite simple, right? It's just 2 lines, but think about this object user as it was like filled with properties. Let's say like it has like 100 different properties, like the address, the email, and all the information of the user. So we don't want to do this for every property. So instead we just use ... user, and that means like make a copy of every property over here. That copy word is important because we are not actually changing anything in this user. We are just making a copy of it, okay? So we need to add 1 to the age, as we mentioned. So after making a copy in here, we can say like, and we want the age to be user.age plus 1, okay? So I just said that this is a copy of entire and then we send age again. Yeah, basically when we write this copy object, this like spread operator with this, basically copying the object, and then we repeat a property in here, this one is overwriting the original one. So in short, it's not that we will have two different age values. We will have a copy of the entire user and we just replace the age value with age plus 1. This effectively will be giving us the 32 in here, but if we ask the actual value again, it will be 31. So we are not changing the original user. We are just making a copy of the original user and adding 1 to the age, okay? We are avoiding mutation and we are avoiding side effects, okay? Now, this also, similar to pure functions, has some pros and some cons. So pros, then again, is reliable and easy to test. Basically, now that we are not changing anything and we are just returning copies of the stuff that we receive, this is far easier to test because we don't need to check like, if we call user next year 3 times, then the year age will be 34. No, it's like every time we call it, the age will be 32 because we are not actually changing the original value, okay? It's predictable because we don't have these surprises that I just mentioned, that suddenly the value of age is 32 and we don't know why, and that's because in some place of the code the value is being changed. If we avoid that and we work with immutable objects, so we don't change any value at all, we just do copies, then everything becomes more predictable because nothing is actually changing. We are just returning copies of stuff with the changes we want on that copy, not on the original, right? And it's more secure because we are not actually changing the original value or deleting stuff or anything like that. We are just sending a copy. We are just taking the value without changing anything and returning a copy. So a lot of really good pros. But if we go to the cons, again, to the bad things about immutability, we have that output sometimes require mutation because we saw this in previous episodes of Untitled WebDev stream. If we output code stuff to HTML, we are actually changing the value of the content of some stuff in the HTML file. So, for example, if we want to show the user name on the page, we need to do something like set the title to the value of the user. So we are changing stuff, we are doing mutations. So that's not pure, right? So we have some like really bad things in there. And also, sometimes it's harder to read. I just explained this to you, so like ... is easier to read once you understand it, but if you are not used to this kind of syntax, let's just make it go back for a second and compare it. Like, this is the bad one and this is the good one, okay? So this one has this ... in here, and this might be harder to read than just doing like user age plus 1. So for people that is not used to this style, this in here is sometimes harder to read than the mutation approach, okay? So basically we have more problems with communication because it's not longer just a problem that we can give like any input or any output because those are impure, but we are even adding the problem that is harder to read for some programmers. So you might start noticing this pattern that basically like all function programming stuff, related stuff is like easier to maintain, easy to test, like everything is better in program, but the thing is like we can't actually communicate with the user, so that's a problem, right? Now, I will address that in like a second. Let's go to the final one. This no control structures convention. So basically, instead of using stuff that is super unreliable, like if, for, while, switch, those things that you learn while you were learning programming, basically, We just use operators, so symbols like ternary operators or nullish coalescence or stuff like that. I will just show you this in like a second. And we use methods, so stuff that comes with objects like functions, pure functions, or sometimes but almost never recursion, so basically functions that call themselves, okay? So then again, let's switch to a little bit of coding here. This is the example for control structures. Let's make it a little bit smaller because my head will be on the way. Here. Yay. So, let me know if you can't read this correctly. If it's like super small or something like that, let me know and I can just like remove my face for like this part, okay? So, we have in here this function called double, okay? And it's hopefully a pure function, let's say. This function only takes a number value and returns that value times 2, okay? So the double. We also have this list in here. So this is just a list of numbers, 0, 1, 2, and 3 for now. It could be like, I don't know, 4, 5, and 6 if you want, but let's keep it simple, okay? So in here we have an example of a for structure in JavaScript, okay? So we want to get the doubles of every item in here. So we want 0, 2, 4, and 6, okay? We want that using this double function. So to achieve that with the structural approach, we just do a constant in here called doubles. So it will be like all the doubles will be in here. And then we need to do this for let I 0 and I is like lower or bigger than, I made a mistake in here. It's like always lower than list length, okay? But those things can happen. That's why I'm saying like it's kind of unreliable, because these kind of mistakes can happen all the time, right? It's like, oh, I forgot to add this, or I accidentally did like, instead of like +1, I did a 2 in here or something like that. So if we want to actually go all over your array or your list, it's kind of like hard to do with this. It's kind of unreliable, but let's continue. So in every loop of this array, or every lab of this array, we want to push to the doubles. So we have these doubles in here. We want to push the double of the current item, okay? So the double of list I. And then we can console log those doubles. So we have 0, 2, 4, and 6. So yeah. The problem with this, and I will show you how to solve it in like a second, is that the only important thing about all this thing that I had to write is actually this part over here. I want the doubles of every item. This in here is just a scaffold code. It's just like we are adding this in order to make this work. But the only important thing in here is this. So we are spending time and effort in something that is actually just to make this work. Doesn't make any sense at all, but yeah. So we can solve this and make it far easier and far easier for our eyes and far better by just doing the following. Just remove all this, okay, and just make list dot map in here. All lists, all arrays in JavaScript have this map method on them. So a method, I explained this in earlier streams, a method is just a function that is inside this. So we have this map function that is inside every list we create. Map will take any function that we want, so a function in here, okay, like let's say like value, okay. It will take a function in here, and whatever that function returns will be the new element of every item. This is kind of complex, but basically, if we put, instead of value in here, we put double in here, we achieve the same thing that we achieve with all this like noise, okay, with all this for stuff. We just do like the doubles will be just a list, like we will map over the list using double. So the double of every item on the list. And this has exactly the same output without all the troubles of having to have a let I and checking if it's actually being added as correctly and all that. We can forget about fors and stuff like that and just use map and it will work, okay? So that will be one of them. It's like, instead of using a for, we use map. Now, we have yet another structure in here, quite usual, like super commonly used in like almost any programming language, called if, okay? So, we have a constant in here that has an age, but we could say that this maybe comes from an API, so let's say like comes from an API, okay? So, let's say like this age is coming from like a user from the API and we want to check if they can drink or they can't drink. I made an example similar to this one in one of the first streams, right? But the thing is like we do this, if age is bigger than 21 then can't drink. So, oh sorry, it's not bigger, it's like if age is smaller than that, okay, there. If age is smaller than 21 then can't drink. And if not, then can drink. Okay, so we have console log twice for every branch of this, and we have all this structure for something that can be expressed quite a little more simple. Okay, so how can we make this simpler? We can just do age whatever, and we do console log in here, and we do age lower than 21. So if the age is lower than 21, and then we use the ternary operator, so it's a question mark, and in here we put can't drink, and then we do this column thing in here that's basically the else branch, and we put in here the can drink, okay? So this line alone replaces all these lines and does exactly the same. One main advantage that this has over if, using the ternary, is that it basically forces us as developers to have all branches covered. This means that basically we can't do something like this in a ternary operator. Every time we have an if, so some condition over our code, with a ternary operator, we must complete both the true value and the false value. So if age is lower than 21, then we show this message. If not, we show this one. With if, we can do stuff like, if the age is lower than 21, show this message. And we don't have any else or anything like that. We are not covering the bad case or the false scenario, okay? So ternaries are not just only shorter, and like we can express it like simpler in like just one line, but they are also more secure because we are actually covering every possible branch of possibility on our code, okay? So yeah, let's see if I don't have that copied anymore. I wanted to show you one more example in here. So we have ternary instead of having an if, okay? So these are the improvements that we did. The example that I wanted to show you just to make something more like connecting with the previous ones was with the for. So let's just, for now, just roll it back to the for. There we go. I want that for over there. Okay, so and there. So one common complaint that the functional programming folks get about this approach of using like map over the for is that for some developers, for some folks, for is easier to read. And yeah, if you are not experienced in programming, you might find this far easier to read than this. But for people that like has a programming background, for are easier to read, okay? So generally what they say is that if you want a function, you can just move all these into an actual function. So we can do something like const, let's make it like 30 doubles, okay? And this will take like any list that you want. So a list in here, list. And inside of that function, they put something like all this code, all this for code, and instead of doing the console log, they return the doubles, okay? So this is like something pretty common, but the thing is, like, if you will be doing this, why not do this inside of that and make it simpler, right? So not only that, maybe even they do something even nastier, like having doubles in here. And having the list over that, and then doing like const doubles, and then like dir t doubles and doubles list. And the problem with this, for example, is that every time we call it, we get even like the first call, we will get this, so that's okay. But the second one, we will get actually this, because this is pushing into the array. So every time we call it, we add more numbers to that. So this is even backed, but this is also something that is pretty common. So instead of trying to justify these kind of structures by putting them inside functions, why don't just use the functions that come with the language and do that for us, right? So yeah, I just wanted to show you that example as well. So let's go back to the actual presentation. So this also has some pros and some cons. So the pros is that they are reliable and easy to test again. So we don't need to think about like, wait, so the for maybe the problem with these doubles is that I forgot to put like the lower than symbol, and I put like a lower than and equal, and that's bad, or maybe not. You need to actually debug every time you have a bug in your code. You need to debug the for besides debugging the actually structure, the array or the list or whatever. In this approach in here, we know for a fact that map works as expected because it's an array of items, okay? So this comes with the language, it's already tested by the browser developer. So we can just focus on checking if double works, and if when we do like a map, we get values with the double value, but we don't need to test anymore. We don't need to test if the for is actually working or anything like that. Same happen with if, so it's like easier test. It's more predictable. Again, we don't have any kind of surprises because the values will always be the same because this map function is actually super pure. It's more secure because we don't rely on actual human error for like stuff like I put the index value wrong or something like that. It works because it's already tested by the browser developers, and it's composable and reusable because I just write this double thing and I can just put it in here and it works as expected. So yeah, if I want to just the double of one simple value, I can just do like console.log in here and do like double of 4, for example, and I will get like an 8 in here. So double like works by itself as a single function, but it also works together with map to achieve this result. So yeah, it's super useful, as you can see. The cons with this is that it's hard to get used to this kind of like programming style when you already are like super used to like classic programming using if and for and while and switch and all that stuff. When you are used to control structures of control in like programming, switching away from that is kind of hard because your head is already super used to think about problems, converting them or transforming them into structures, and that's like actually an issue with like how programming is taught in schools and universities. It should be focused more about like actually thinking about how to solve the problem and now how to transform a problem into a different one, basically, because you are transforming a condition into an if, or you are transforming a repetition into a for, and you shouldn't think about problems like that. You should think about the actual solution, and the tooling around that is just like different ways of writing the solution, okay? So, recapitulating is like a correct word. Let's say like summing up all the pros and cons that we saw so far. We have that functional programming in general is more reliable and easy to test, it's more predictable, it's more secure, it's more composable and reusable, it's easier to read and reason about, okay? So it's like generally easier, okay? But we have the cons on the other side, and the cons is that it's hard to get used to it when you have experience with other languages. So if you come from languages like Java or C++ or C# or whatever, it's hard to adapt to that. And it's hard to communicate with the external world because the input and the output, as I mentioned previously, are impure. So this is useful, this is super useless, and we should keep using object programming languages. Actually, no. A few years back, in web development, we received like the savior for us, like the thing that made functional programming possible. And that savior was called React. So I talked about this library a lot and about the stuff that it introduces, but I sometimes don't mention that I didn't like this library at all when it came out, okay? So I was programming in TypeScript at the moment, and I was super, like, I really like stuff like Angular and stuff like that, but the thing is, like, I initially focused on the wrong thing, okay? So as soon as I saw React, I saw this language that combined like JavaScript with HTML in like a really nasty way, and I was like really disgusted about that. But the thing is, like, I was wrong. I was really wrong, okay? So I missed the point of React and what it provided. Basically, React is not about mixing HTML inside your JavaScript. It looks like that, I know. If you have no experience with functional programming and you don't have any experience with React in general, it's like, it just looks like you are putting HTML inside your JavaScript, and it's disgusting, okay? But React is actually about forgetting about the mutations of the DOM. So as developers, we can focus in the actual components. We can think about stuff like buttons and like I don't know, like titles and stuff like that, and we don't think about stuff like how can we update the DOM to show the title. So basically, React and libraries like it, so you have Vue 3, for example, it uses actually the same techniques in the background. Preact, Inferno, Rhythm, and other libraries like that. They take care of the logic behind turning our stateless components into functions, okay? So we basically write just functions, pure functions, as the one I showed you just a few minutes ago, and React or Preact or whatever, or any of these libraries take those functions and they take care for us of all the mutations on the UI. So changing, for example, the titles and the images and showing stuff on the screen. React takes care of that. So we can just focus on creating components. So, in short, this VDOM concept, the virtual DOM concept that React brings to the table, enable functional programming for the web. Okay? To make it more clear, let's check some of the code that we already wrote. So let's just check if I have in here open recent, and we have episode 10 maybe. I think that one was about React. So let's switch to it for a second. Yeah, so this is the React one. Let's go to like the bottom, okay? Open it in here. So, for example, in here, I have this button component that we wrote from one of the previous episodes, for episode 10, okay? And this button has like this class name. It has this property that we added that is called backgroundless, because we wanted to not show the background on some scenarios, okay? So that basically meant that we wanted to add a class every time this was true. That was super easy to achieve because basically on the app in here, we have, let's look for button. Oh, it's back here, right? Yeah. So we write the code like this, like button backgroundless, and this is adding a class to that button, but it's doing that automatically for us. We are not thinking about, okay, I want to add a class, so we need to do button dot class name equals something, or class list add or something. We don't need to think about that. We just express the button as a pure function, because it's just a pure function. It takes an object and always returns the same if it receives the same properties. So this is basically a pure function. And this pure function basically says that every time we receive a true in here, the class in here will be backgroundless. And if we receive a false, we will not have that backgroundless class. But we just write this in here. We don't need to deal with the logic of removing or adding that class. React is doing that for us in the background. So basically, we are doing functional programming for UI, for developing user interfaces, without having to think about the mutations. So all the cons that we have with functional programming of not being able to communicate with the user or receive information from the user is handled by us in a pure way. So basically our code is pure. In the background, yes, to be completely honest, React is doing impure stuff. So React is doing the impure bits for us. But the good thing about that is that React is abstracting us away from that. So we don't need to think about mutations or anything like that. We can just focus on doing our code immutable, with pure functions, without side effects and all that good stuff. And React can deal with all the nastiness of the DOM and doing the mutations for us. So we can just test and have a super easy to maintain code without having to deal with the actual hard part that is being dealt by React, Preact, BDOM and all those libraries that are out there, okay? So I think the next one is So before I close up this presentation part of the functional programming things that we are talking about today, I wanted to talk about other options that we have in front end. We have Elm and PureScript. So it's not that you need to use JavaScript in order to have functional programming on the front end. If you want to go the extra step and go to a different language to develop in complete functional approach, so you can go to Elm or PureScript. These languages basically don't allow you to code in other way that is not functional, okay? So for example, we can go to Elm's website. Let's switch to it for a second. Elm lang. So this is Elm's website. This logo is super fun to play around. But basically, this is a completely different language, okay? So it's not JavaScript, it's not TypeScript, it's a different language. But it's a functional programming language that when compiles, similar to TypeScript, that it compiles to JavaScript, well, this does the same. You code in a functional programming language and it compiles to JavaScript. So it works for doing web apps and stuff like that, but it forces you to actually do functional programming. So we can check, for example, let's go to the hello world. So in here, we have an example of the code. This is a really short example. Let's maybe do groceries is one. Yeah, so this has a list. This is a completely different language. This is not JavaScript. This compiles to JavaScript, there is not JavaScript. But the good thing about this is that first, Elm forces you to actually write code that is functional. You can't do something that is not functional. You can mutate values. You can go ahead and do a for because of reasons or something like that. It's just functional, okay? And the second thing about really good about Elm is that, as I think they say in here, you have no runtime exceptions. This is because, similar to TypeScript, Elm is typed, okay? So you need to have types for everything you write. And the good thing about that is that when you write something and it compiles, so basically it produces the final JavaScript, you are certain that that will work forever, basically, because you will not have runtime exceptions, meaning that you will not have something that happens all the time in JavaScript, like I can call a function inside undefined, for example, or undefined is not a callable or something like that. It will not happen because this checks before compiling the code, and is so good that you will never end up with an actual problem in production. So in the final product, you will spot all the issues before they reach the final user, okay? PureScript, on the other side, is more like, it's a mixture, let's say like a middle ground between TypeScript and Elm. It's super similar to Haskell, this programming language that I mentioned at the beginning of this presentation of sorts. But yeah, the problem I see with this, with PureScript, is that if you will go this route of going to like another language, then just go ahead and use Elm, okay? And if you want to have something that is kind of like not so hardcore functional programming, you just want to code in a functional programming style, but at the same time you just want to keep on working with JavaScript or TypeScript, just use TypeScript, right? PureScript is like a middle ground. If you maybe it's good for a transition. Maybe if you are working with TypeScript, you could like just test PureScript first and then switch to Elm. But I personally, I would not recommend like PureScript, or like personally, I'm showing you to like see that there are several options, but like personally I will not use this. If I need to use another language, then I will just use Elm instead. So yeah, the final one, let's just I already spoiled it, but whatever, is that the closing thoughts for this is that functional programming basically makes our code easier to read, so we have like a really fast development, because we don't need to like go ahead and ping our coworkers or something like that in order to ask them about, hey, how this function works or something like that. It's always like super obvious because functions are smaller and easier to read. They are easy to reason about because we don't need to think like, hey, so I called this function like 3 times, so maybe the value is different. No, it's like the output of the functions is always predictable if you work with pure functions, so the debugging is like far better. It's easier to spot issues because the issues are generally with the data, not with the actual like functions that we wrote. It's easier to maintain, so if we have any kind of issue, this reuse that we saw in the different examples that I showed you already allows us, for example, if we have let's say an issue with the double function, right? So the function that takes a value and returns the times 2 value, okay? Maybe we have an issue with that function. We can just fix the problem in double, and that will fix the problem in all the places where double is being used. So we keep our, like, it's far easier to maintain, so our code keeps being having like a really high quality, right? It's also, as I mentioned time and time again, super easy to test, so our code is more robust because we can test for different scenarios, for all the possible scenarios, because it's super easy to do that. And more robust is basically that we are sure that our code will work in any scenario because we test for that, right? And I use this in the easy to maintain, but yeah, it's easy to reuse, so the profit that we get from this is higher, because basically if you have like your own startup, or if you are working in a project even, you can create like a set of utils or stuff like that is super usable, and that could be used in other projects. So basically, instead of like doing everything again every time you start a new project, you just reuse the stuff that you create for the previous one and you keep on improving on that, right? So basically everything is easier, so everything is better, okay? It's easier for us as developers, and it's better for the clients and for the general consumer of our products. So yeah, that's like the cool presentation part. I don't know if anyone in chat has any kind of questions about this in general. The most common question I had, and I already answered that, is that if we don't mutate, so if we don't change any value and we create stuff from scratch, how does that affect performance? And the hit on performance is super low, so it's not something to consider. But besides that, it's like, if you have any kind of questions, I can answer those, and if not, we can just like call it a day for today. It's like, it's been an hour already, and maybe it's super tiresome, but yeah. Also, before I'm closing already, and I didn't want to close already. Also, before I go to like the actual close, remember, I mentioned this at the beginning of the video, but just in case, that if you have any kind of extra question about functional programming in general, you can just like go ahead and ping me on any of my socials that I will be showing you in the next link. Or if you are seeing this on YouTube later, you can just like leave a message in the comment down below, and I can just like address it in there or in the next video. I still didn't figure out what the topic will be for the next video. I might focus on like keep on improving on React knowledge in general, and maybe like make or React app communicate with some kind of server or an actual API. Or this was suggested by a YouTube comment, I could just show you how JavaScript in backend works, for example with stuff like Express or Koa, that are two libraries that are super popular to do in like backend with Node. And I could show you like how to handle that with maybe a MongoDB database in order to have like, let's say like not a full stack approach, but like just show you how the backend works with Node and with JavaScript. But yeah, that could be it. Like, let's make that the topic for the next talk. But yeah, let's call it a day. I guess as usual, I'm super thankful for you to like stop by to watch the stream for a while. Again, I say this again and again because I know that developers in general are quite timid and they are shy, so it's like kind of hard to address someone that you don't know. But feel safe and like just go ahead, and if you have any kind of questions related to web development, or maybe to like stuff that I talked in previous episodes, like the interview process or stuff like that, go ahead and just ping me on like, I don't know, like Twitter or Telegram or anything like that, and I will be happy to help you like grow up as a developer. But without anything else, you have my website now on screen with like it will take you to like my most commonly used social media. But yeah, that's pretty much it for today, and like thanks a lot for watching, and I see you next time.